All right, so today's lesson is trying to find the area and perimeter of different figures, right? So you definitely want to have some sort of calculator with you. So the perimeter of a plane figure is just the distance around the figure. So you're basically looking for the distance around a figure, which really just means that you're going to add up all the sides. The area of a figure is going to be the region that's enclosed by the figure. You always measure area with square units. So these are the formulas that you should know already. So a square or a rectangle, the perimeter is going to be twice the length plus twice the width. If it happens to be a square, and you think about S being the length of a side of the square, you could always say P equals 4S. That's only, again, if you're talking about a square. The area for a square of the rectangle is length times width, or base times height. A rhombus, which also has all four sides the same, just add up all the sides. And then in terms of a rhombus, there's diagonals of a rhombus. A diagonal is any sort of line segment that connects from one vertex to another that goes through the center of the, or goes through the shape. This would act as a diagonal. Diagonal 1, let's say. This would act as a diagonal. We'll call that one diagonal 2. So the area of a rhombus, again, a rhombus has four sides congruent, no right angles. The area of a rhombus is half of the product of the diagonals, 1/2 d1 times d2. Circle, we don't call it perimeter, we call it circumference. So circumference of a circle is 2 pi r, or pi d, r being the radius. So double the radius is just the diameter. The formula for the area of a circle is a equals pi r squared. Triangle, just add up all the sides. The area of a triangle is half the base times the height. Trapezoid is the sum of all the sides for the perimeter, and the area of a trapezoid is 1/2 the sum of the bases multiplied by the height. Okay, so when we start doing the math, again, feel free to have your calculator. I'm going to go back and forth between the calculator or not. But if the circumference of the circle is 10 pi inches, what's the area of the circle? So circumference, we know, C equals 2 pi r. Well, we also know that 10 pi is the circumference. So 10 pi equals 2 pi r. Well, to find the radius, I could divide both sides by 2 pi. And what ends up happening is the radius just is equal to 5. Okay, because again, anything divided by itself, 2 and 2, pi and pi, is just 1. So 10 over 2 is just 5. Well, now we've got to find the area, knowing that we have the radius. So the area is pi 5 squared. Your answer should be 25, and that's centimeters squared, or inches squared, but they told you that in the question. Take a look at the next one. It talks about a circular garden, has a diameter of 12 feet. How many bags of topsoil must Linda buy to cover the garden if one bag covers an area of 3 square feet? So let's see what we need in terms of the area. The diameter we know is 12 feet. If we want to be able to find the area, we've got to find the radius. So the radius is just half of that. So the area of any circle is pi r squared. The area becomes 36 pi, right? Radius is 6. So once we've got 36 pi, we can multiply this whole thing out by pi and then divide that by 3. So we know one bag covers an area of 3 square feet. So here's what the calculator is going to come up again. Well, we can do it this way. So we know that the topsoil that's needed is going to be whatever 36 pi is, but we're going to divide that by 3 because one bag covers 3 feet. So what we're going to do here, let me try to get to the calculator, is we're going to do 36 pi. So I'm going to go in here, 36 pi. That's what the area is. Let's go back. 36 pi. It's not working for me. Let me go to my desk. All right, give me 1 second. Let's try this again. Okay, so then we've got the area of the circle is 36 pi. And we know that because one bag covers 3 square feet, well, how many bags do I need? So I'm going to divide it by 3. And you get into 37.699. So basically, you can't buy 37.69 bags. What you're going to have to buy then is 38 bags. Okay, so make sure you're good with that one. All right, so then here's a question for you, and it's already filled in. But how would one determine the area or perimeter of a geometric figure that is comprised of more than one shape? So what you're going to have to do is find the area or perimeter of each individual shape and then adjust it to the figure that's drawn. So what's happening on this particular problem is you have a square and you also have a semicircle, a half of a circle. So what you're going to do here is you're going to say, okay, well, if I'm looking for the area in this case, the area of a square we know is base times height, which is 16 by 16. So we know that the area of the square happens to be 256 inches squared. The area of a semicircle is pi r squared divided by 2, right? We've got half a circle. The area, this is supposed to be of half of a circle. It's like taking a circle. Doesn't really look like that, but that's what it is. So the diameter of this circle happens to be 18, which means the radius has to be 8. So what we're going to do here is we're going to say, all right, well, 8 squared is 64 pi. We're going to have to divide that by 2, which in this case just becomes 32 pi inches squared. Well, all we have to do is get those two things, add them together, and then we're going to have our answer. So what we're going to do, and let me actually come down here for a second. So all we need to do is find the area of square plus area of half circle. And that's what we're going to get in 1 second. Let's come up to here. And what do we have? We've got 256. We're going to add that to, and I'm going to put it in parentheses, half of the circle, or 32 pi. What comes out in this case is 356.53. So we're going to do it to the nearest tenth, and we're going to make it 0.5. So it's going to be, can I get back in here? It's going to be 356.5 inches squared. This has to be raised, and there's your answer. Okay, so we've got the answer right here. Make sure that's good before we go to the next one. All right, so next one, we have this ice cream cone, which is basically, and I'm going to sort of put this up again, we need to find what the area of a triangle plus the area of half a circle. That's what we're looking to do. So let's see if we can get that done. So the area of the triangle is base times height divided by 2. So let's get over here. Area of the triangle equals base times height divided by 2. The base and the height are formed by the right angle. So 12 by 14 divided by 2, which I believe is going to be 84. The area of half the circle is going to be pi r squared divided by 2. Well, if the diameter is 12, the radius is 6. So we're looking to have 36 pi cut in half, or 18 pi. So the area is going to be the sum of those two. So what we're going to do here is say, where's my key? All right, so we're going to now clear this out, and we're going to say, well, 84 plus, and again, I like to put things in parentheses, 18 pi. Get that answer, 140.54, which is going to be 140.5, so that's our answer, 140.5 centimeters squared. And here you go. All right, so we've got our answer then right here. And we'll move on to the next one. So a window is made up of a single piece of glass in the shape of a semicircle and a rectangle, as shown in the diagram below. Tess is decorating for a party and wants to put a string of lights all the way around the outside edge of the circle. outside edge of the window, sorry. To the nearest foot, what is the length of the string that Tess will need to decorate the window? So remember, she's going to go all the way the outside of the window, which means we have to go here, here, here. Those are the stray pieces. And then we have to go around this curve. So we got to figure out what's going on. Well, we have a rectangle here. And we need to get this opposite side in yellow. We've got 12 by 10, sorry, which means this is 12, which means this guy is 10. Well, we only need the 12, the two 12s in the bottom, 10 in yellow. So we've got to do 12. This is perimeter, by the way. So we've got perimeter equaling 12 plus 12 plus 10 plus half of the circle. Well, in terms of the circle, we're dealing with the circumference. So the circumference for half of the circle equals, let's do this. Circumference of half the circle equals 2 pi r divided by 2. So really, you just need pi times r if you look at that. We know that r happens to be 5. So this is really going to be 5 pi. So what we need in terms of the total foot of string is we have to do 10 plus 12 plus 12, which happens to be, so perimeter happens to be 2434 plus 5 pi. So let's see how much that is. Let's go back to the calculator. So again, we're looking for the straight edges, which all give you 34. Half of the circle gives you 5 pi. And what comes out here is 49.7. And they want that to the nearest foot. So the nearest foot, that would be 50 feet. Okay, so we're looking for the answer of P equals 50 feet. Okay. Let's take a look at the next one. Is that the end? Yeah, okay. So the next one. Lewis is going to paint a basketball court on his driveway as shown in the diagram below. The basketball court consists of a rectangle and a semicircle. Which expression represents the area of the basketball court in the semicircle? Well, that means we've got to find the area of a rectangle and the area of half a circle. We keep doing a lot of these half circles here. So we're looking for the area of rectangle plus area of semicircle. So that's what we need to get, which we know that when we do all of that, see if I can even do this here, which means we're going to do base times height. Let me get out of, okay, that's okay. So then we're looking for, I'll come back up to the board. So the area of the rectangle plus the area of the half circle. The area of the rectangle is base times height, which is 8 by 10, which is 80. The area of the semicircle is going to be pi r squared divided by 2. Remember, the diameter is 8, so the radius is 4. 4 squared is 16. So we're looking for 16 pi divided by 2, or 8 pi. All that we have to be able to do is just add those two pieces together. So let's see if we can do that. Come back to the calculator. Let's see. Calculator, slide this over. So we're looking to have 80 plus 8 pi. And then the answer that we get is 105. Oh, actually, that's what they want. If you look at the what expression, they don't even want an answer. It's 80 plus 8 pi. So there we go. So should have actually stopped and looked at the answers. 80 plus 8 pi is going to be your final answer. Okay, so that is it. The rest of the homework, or the rest of the stuff, is the homework. And don't forget that you are looking for area and perimeter of both of these shapes. So don't just do one, you're looking for area and perimeter, okay, of both of those shapes. And then you got a second page here also, and you should be good. All right, so good luck on the homework.